Hi, so let's take a look at question number 2. So water is pumped into a tank at a rate of WT equal to 32 gallons per minute. And water leaks out of the tank at the rate of RT equal to 2T squared gallons per minute. For the time between 0 and 10 inclusive, at T equals 0, the tank contains 500 gallons of water. So we know that the rate in is going to be WT, the rate out will be RT, and the initial amount is 500. Let's take a look at part A. Is the amount of water in the tank increasing or decreasing? So if you let P of X equal to the amount of water in tank. So amount of water increasing or decreasing, it means, okay, that P of X increasing or decreasing at T equal 1. So for increasing or decreasing a function, we're going to use the third derivative. So we have to use P prime of 1. Okay, so that is the idea behind the question. So now we're going to show the work. So we say that P prime equal to the rate in minus the rate out. So P prime is going to be the WT minus RT. And P prime of 1 will be W of 1 minus R of 1. So we get W of T equal to 32, so W of 1 equal to 32. And then we get RT equal to 2T squared, so R of 1 equal to 2 times 1 squared, which is 2. So now we go back here, we got 32 minus 2 equal to 30. So P prime of 1 equal 30 is positive. So the amount of water in the tank is increasing at T equal to 1. So for number 2, I'm not going to show the other method. If you want to, you can use the other method that you like. So we finished part A. Now let's take a look at part B. At what time T, and T is between 0 and 10 inclusive, is the amount of water in the tank is an absolute max. And then at what time T is the amount of water in the tank is an absolute min, justify your answer. So now we are going to use P prime. So we talked about before, if you want to do the absolute max or absolute mean, you have to let P prime equal 0 and find the critical value. And then you are going to check, okay, so how many latitude max and latitude mean that we have. So we have P prime equal to the rate in minus rate out, which is WT minus RT. So the rate in minus the rate out. So we're going to make WT minus RT equal to 0. And that means 32 minus 2T squared equals 0. And then I plus 2T squared both sides. So I got 32 equal to 2T squared divided by 2. So we got 16 equal to T squared. And then new T equal to 4. We're going to omit the negative 4 because the time cannot be negative. So now we are going to draw a side chart. So we got the time interval 0 to 10 and put 4 in the middle. So we got P prime equal to 32 minus 2T squared. So we can use endpoint 0 and we use endpoint 10 because inclusive. So we got 32 minus 2 times 0 squared, we're going to get positive. And then we're going to have 32 minus 2 times 10 squared. So we got 2 times 100. 32 minus 200 is going to be negative. So now we're going to have positive slope and negative slope. So we got P of 0, P of 4, and P of 10. So we found out that there's only one relative max, so then it had to be the absolute max. So P of 4 is the only relative max. You have to say this. Then it is the absolute max. Because of that, we don't have to compare. So the amount of water is absolute max at t equal to 4. So we got two relative mean. Then we have to compare. So P of 0 equal to 500. And then we have to find P of 10. So we got 0 to 10 Wt dt minus 0 to 10 of t dt n plus 500. That's the initial amount. So we got P of 10 equal to 0 to 10. So we have Wt is 32, so the 32 dt. And then integral 0 to 10 RT is 2t squared. Now we're going to integrate. So we get 32t, and then 0 to 10, and minus 2 times t to the third power over 3, and 0 to 10, and plus 500. So now we got 32 times 10 minus 0. And here we got 2/3 times 10 to the third power minus 0, and plus 500. 320, and minus. So this one will be 2/3 times 1,000. 30. So now I get 320 minus 2,000 over 3 plus 500. So now I'm going to add this together. So I'm going to get 820 minus 2,000 over 3. So 820 times 3. So we got 2,460 divided by 3, subtract 2,000 divided by 3. And now we got 460 over 3. Now we compare these two numbers, see which one will be going to be the absolute mean. So 460 divided by 3, you can divide it, or you can convert this one into a improper fraction times 3. So definitely this one is bigger than this. So P of 10 is going to be the absolute mean. So the amount of water is absolute mean at t equal to 10. We finished question number 2.